We are going to have the same learning goal that we had yesterday, and it is being able to simplify expressions that have rational exponents. Rational meaning what again? When you hear the word rational, you need to think of what kind of a number? A fraction. Okay, so when we have fraction exponents. Well, yesterday we were able to get a value for it. Today we're going to get a simplified variable expression on these four that we're going to practice on the front side. So we are going, I want you to be this detailed in your notes like I'm going to be with you right now, so that when you refer to your notes, just try and remember how to do it. You can see each and every step we took. If you don't show each and every step in your homework for tomorrow, that's okay, but you do have to show some sort of work to convince me that you know what you're doing. You need something, Jay? Oh, no, okay, good. Okay, so let's start by, first of all, I want us to write this first one as a power. So how could this be written as a power? First of all, what would the base be? X to the 4th, y to the 12th. That's our base. What power would it be raised to? The what? Say it louder. The 4th power. Everybody agree it should be raised to the 4th power?
Oh no.
I don't think so. Look at yesterday's notes.
1/4 power.
1/4 power. When we are finding the 4th root, that's what the way it's written. Find the 4th root of x to the 4th power, y to the 12th. When we're finding the 4th root, that is the same as taking it to the 1/4 power. Now tell me something about that base. That is, we put in parentheses there. What is that, so we know which property to apply here? What would we call x to the 4th, y to the 12th? You might have to get off that sheet that we did at the very beginning of the chapter that reviewed properties. What is x to the 4th, y to the 12th? Is this a power to a power? Okay, the x to the 4th, y to the 12th, raised to the 1/4 power is a power to a power. I will agree with that. Right now I want to know what is x to the 4th, y to the 12th. What's going on there? Multiplication. So what would we, which property should we look at?
But you can't because they're on the same page.
We don't have the same base, so we can't use the power times a power, can we? I think there's another one though that has something to do with multiplication. Which one is it?
Product raised to a power.
A product raised to a power. This is a product, x to the 4th times y to the 12th. We have a product going on there, and it's being raised to a power. So what's our rule for that? What do you do when you have a product to a power?
Power to each.
Give the power to each, what? What are those called?
Factor.
Factor. So x to the 4th is going to get its own power, and the reason we're going to use parentheses is because we are raising a power to a power here. So we're giving the factor x to the 4th its own power of 1/4, and we're giving the y to the 12th, the other factor, its own power of 1/4. So we're applying the product to a power property. Now what property should we use next? What, Carson? A power to a power, okay? And what did we do when we are taking, how do we simplify a power to a power? We multiply them, what's them? The exponents, and we're going to show this so that our notes are very complete. This might possibly be the step you would not show in your homework because you're like, I know I have to multiply, but in your notes I would like you to have what we're actually doing here so that, I don't like what I just did to that. And by the way, you know, again, I'm gonna say, make those exponents look like exponents. They're superscripted, okay? Well, now, what is 4 times 1/4, or 1/4 of 4? 1. X to the first times, what is 1/4 of 12? 3. Okay. It appears about the only thing left is the power times the power, right? Can we add their exponents then? Why not? They don't have the same base, so all we're gonna do is clean this up. What would this clean up to? X, we'll ditch the 1, the power of 1, we'll ditch the multiplication dot, and we'll leave our answer as x, y to the third. Questions? Here, our next one is a fraction. So when you have fractions to simplify, first worry about simplifying the numerator and simplifying the denominator independent of each other. So they'll still stay together as a fraction, but we're going to take care of each floor independent of the other. So what's going on up in the numerator floor? What's that called? X, y to the 1/2 power. What is that? A product again? X times y to the 1/2 power. So that is a product being raised to a power. So what do we do again? Give that power to each factor. So the x is going to get the factor of 2. The y to the 1/2 is going to get the power of 2. That takes care of our numerator. Downstairs, I want us to write, instead of that being the 5th root of x to the 5th, how can I write that as a power? X to the 5th power raised to what power? The 1/5 power. When it's the 5th root, that's the same as raising it to the 1/5 power. My 1 and my numerator is kind of hidden in that y tail there. There's a 1 here. I'll make it blue or red. Okay, now let's, it looks like everywhere we have powers to powers, right? Because really here we have x to the first, right? So that becomes what? X squared, okay? What are we going to do with this one? We're going to show that step even though it seems kind of silly. When we're taking a power to a power, we multiply the exponents. Downstairs, same thing. We have x to the 5 times 1/5 power. You already got the answer to this, Brady?
Yes.
You do. Okay, what's the final answer?
X squared y divided by x.
Okay. Anybody else doesn't do it? Agree with Brady?
Well, you have to simplify it more after that.
Oh. So stay tuned in, Brady, okay?
Alright.
Okay, thanks. So x squared is x squared, right? And what's half of 2? 1. And what's a fifth of 5? 1. So this is where Braden says, okay, I'm just going to clean it up. I'm going to make this x squared y over x. And Carter says no, and some of the rest of you are seemingly agreeing because why? You can't have x's in both floors. That means you can simplify some more, right? So there's 2 ways to simplify this. We can say there's no addition or subtraction. This is really important that you always hear me on that. When there's no addition or subtraction going on upstairs or downstairs, we can just divide whatever pieces we want. So we can divide that. And division says, division of powers with the same base says, do what with their exponents? Subtract them. So this would become x to the 2 minus 1 power times y to the first. So then this would become x to the what power? First power times y to the first power. And that could clean up to be xy. Now, you know, for some people, for some reason, this kind of like dividing thing, especially when everything doesn't divide by, you just kind of feel like you can't get away with that. So you know what, there's another option you have. X squared means x times x, am I right?
Yep.
And then times y to the first means just times 1y. And then I have an x to the first downstairs. So now, because there's no addition or subtraction again, what can I do? I can cancel what? I got to take out some x's, right? I got an x up, I got an x down, I can cancel those out, and look at what's left. xy, right? So if you like it that way better, do it that way. Okay, you try the next one. Remember, we're being really particular. We're showing every little step in our notes. What did you guys get? Z? Everybody in favor of Z? For the answer? No arguments there, really. You could be the one who's right. Are you going to agree with it? You think it's 1? Anybody want to go with 1? Well, a couple of people are doing it, but not very assuredly, kind of like. Okay. Okay, what else do we get then?
Oh, wait, actually,
What do you want? You want 1. Okay, Carson? 0. Okay. Anybody want 0 with Carson? Okay. We got 0, we got 1, we got Z. Oh, well, there can only be one of those, so, because they don't. What would you do? What, did you get to this part where I got to? Did that happen to anybody? Z to the first over Z to the first, do you agree with me there? Yeah. You subtract the exponents, okay, well then that would be Z to the 1 minus 1 power, which is Z to the 0 power, and anything but 0 to the 0 power is 1. I guess you all should agree with the list. Oh, you know, I think we're having a really hard time grasping that properties. I noticed this on that bell ringer when I was correcting that. There was an L to the 5th over an L to the 5th. Anybody remember that one? If you haven't taken it yet, you might not. And I saw, you know, some people got it right, and some people they were kind of convinced that maybe it was L, and then I saw, I don't know, I saw all kinds of crazy things, but I think somewhere along the line, you guys did not grasp the property that says when you multiply something, when you divide something by itself, other than 0, 0 is the only nitwit that can't be a part of it. When you divide anything by itself, the answer will always be 1. 3 divided by 3 is negative 2 divided by negative 2 is A divided by A is no. It's 1. Anything divided by itself is 1. Because here's the deal, folks, in an expression, the same variable cannot represent two different numbers. So when I have a over a or z over z, I have to pick a value for that variable, and no matter what value I substitute in, I have to substitute it in upstairs and downstairs because I have to have the same one. So if I picked 10 for z, and I would put 10 over 10, what's that? What's 10 over 10? 1. If I pick negative 2,000, what's negative 2,000 over negative 2,000? So it does not matter if it's a variable or not. Anything divided by itself is 1. Anything divided by itself. So we really only had to, right here we could have said, oh, you know what? That's 1 because it's something being divided by itself. But this proves that it should turn out to be 1, doesn't it? Questions? Okay, well then you should be ready to do the next one. You got this. Every single property that gets applied, you should be showing the work. Because these are your notes. It's always good to have good notes. Can I have your time?
No.
Why not?
You just simplify.
I have more simplifying to do. What can I do?
Subtract. Why didn't you put the exponent for b?
I have a b to the first here.
Oh,
Isn't, yeah, it's kind of like, it's there.
subtract b to the first from b to the second.
Oh, so there's no addition or subtraction upstairs, so I can take these guys and say, okay, a to the 8th, come along with us. It's b to the 2 minus 1. Or remember I said we could write this out. Well, I don't really want to expand all those a's and I don't really need to, so I'll just expand the b's. And what's 2 minus 1? 1. So I have a to the 8th times b to the 1st, and that can be cleaned up how? A to the 8th b. And that's what will happen over here, won't it? A to the 8th b. Okay, you got this? You can do this? Okay. No questions? You have anything here in my page yet? No? I'll give some money back to this month. I keep track of how many questions you ask me, and if you don't ask me enough questions, then I have to give some money back on my paycheck. Oh, and I don't have very many tally marks ever, it stinks.
It's okay.
It's okay that I don't get so much money, okay. Let's go back then, let's go. 8/27 to the 1/3 power. Now we do know that variables involved. We have a fraction being raised to a fraction power. But of course we know what to do when we have a fraction being raised to a power. What do? What property do we apply now? A fraction being raised to a power. What would we do?
Oh, fraction raised to a power.
What do?
Oh, you distribute the variable, the exponent.
You
each
give
part of
the
fraction.
exponent to both the numerator and the denominator. Oh, you don't remember this?
What's the last one on our thing?
Well, now this is kind of looking like yesterday. We're taking a number to the fraction power 8 to the 1/3 power. What in the world would that be? 8/3?
Yeah.
What does 8 to the 1/3 power mean?
Times
Two.
times.
So multiply 2 times 2 times 2, you get 8 plus 2 times 2 is 4.
Oh, I know.
So in other words, the 3 is saying we need some number times itself 3 times. That will give us 8. So we need what times what times what equals 8. And that is 2, did you say, Dylan? Okay. So 8 to the 1/3 is only one of those 2's. So we get a 2. And then what does 27 to the 1/3 power mean?
3.
What times itself 3 times gives you 27, and that is 3. Oh, you guys are getting so smart. And we only need one of those because we want the third root. We want the number that is the multiplier, and so our answer is 2/3 if we can't simplify it anymore. Can we simplify that anymore?
No.
Yes or no? I heard both, so I'm not really sure.
No.
Okay, I don't think so either. Okay, well, we're going to just remind ourselves that really, when we have a fraction to a power, because some of you are like, I didn't remember that. Well then, here's what you have to do instead. You have to say to yourself, okay, well then I have to figure out what times itself 3 times will give me 8/27ths. Now, I'm not sure that very many of us in here can kind of instantly say, well, that's 2/3. You did, Connor? Okay. So we are really looking for what number times itself 3 times gives us 8/27ths. So write that out for me, please. That's what we're really looking for. So maybe, if you're as smart as Connor says, he says, I got it, so maybe you did too, I don't know. Then you would show this instead. You would say, oh, I know that 2/3 times 2/3 times 2/3 will give me 8/27ths. Because 2 times 2 times 2 upstairs is 8, and 3 times 3 times 3 downstairs is
27.
Well, look at there. I guess, maybe you can do that. So there's a couple of different options here for how to show your work. No what?
Calculator.
No, it's like a bad word in here. Okay. 4/49 raised to the 3/2 power really means what times itself how many times? Is it the 2 or is it the 3? Look at yesterday's notes when we had a numerator greater than 1. Which one was it? Was it the numerator or the denominator?
Denominator.
It was the denominator. So, in other words, this could be rewritten as 4/49 raised to what power? The 1/2 power, not the 2 power. The 1/2 power. Remember how we renamed these as powers to powers? Well, because we got all kinds of stuff going on here. We got a fraction that has to be raised to a power, so we have to put the fraction in parentheses so that we know the whole fraction is taken to the power. And then we're going to take that power to another power, so now we're going to use another set of brackets, and it's going to be to the 3rd power.
Yes.
Because remember, 3 times 1/2 is what? What's 3 times 1/2? 3/2. Remember, it has to take us back to what it came from. So, what times itself twice, let's do it twice instead of 2 times. What times itself twice is 4/49, that's what we're going to be looking for. And then take that answer and cube it. So, and that cube. So, we are looking for what times itself twice is 4/49. And then we're going to take that answer to the 3rd power. So let's just do it like this. This can be given, each of those, 4 to the 1/2 power. Does that mean this? Does 4 to the 1/2 power mean that? The square root of 4? Yes. Yes. And does 49, because each of these would have to get their own 1/2 power, right? Remember, they each have to get it. It's a fraction to a power, give the numerator the power, give the denominator the power. So we got to give the 49 the 1/2 power also. Would it be that? The square root of 49? Yes. That is going to get taken to the 3rd power. Kind of looks a little friendlier now, doesn't it? Because what's the square root of 4? 2. And what's the square root of 49?
7.
Okay, so now it's, it's starting to get a little friendlier all along, isn't it?
Yeah.
Okay, and now what are we going to do?
2 to the 3rd power and 7 to the 3rd
Yeah,
power.
we have 2 options here. We could take 2 sevenths times 2 sevenths times 2 sevenths and see what that gets us. Or we could say 2 to the 3rd power over 7 to the 3rd power. What's 2 to the 3rd power?
8.
8. 7 times 7 is 49, and 49 times 7 is 343. Did you do that without a calculator?
Yeah, I did.
You did. Wow, that's awesome. So our answer is 8 over 343. If I circled it already, oh no, can it be simplified?
Let's
No.
check.
What goes into 8?
2.
2,
No,
4,
6.
No,
can't.
8.
Yes.
Okay, so we gotta check to see if 2 goes into 343, does it?
No.
No. How about 4?
No.
You're sure?
Yes.
How about 8?
No.
Okay, then we must be safe.
Yes.
We must be
Yeah.
simplified. Okay. Okay, you try that last one on your own. Go. 8 over 125 raised to the 4/3 power. Oh, this is a lot of work. And the answer is?
16 over 625.
Everybody get that?
Just wait.
I wonder where that comes from. 2 to the 4th over 5 to the 4th. Huh, well, 2 to the 4th is 16. And 5 to the 4th is 625. And can it be simplified some more? Are you sure? Unless you want to make it a weird decimal? Yeah, that's not called simplifying, we make it a weird decimal. Okay, so we're gonna say that nothing goes into 16 and also goes into 625? Correct, oh, okay, then we're gonna circle that and say we're done.
We're done.
Okay. Show your stuff on your homework. Got it. I'm coming to look at those notes, remember the check it out problem, don't put them away. Because you were here yesterday, you had to finish it on your own.
We got 3